Most of us picture the universe as a massive, empty box, a container for stars and galaxies, with a cosmic clock ticking quietly in the background. Standard physics describes the Big Bang as a sudden explosion of matter and energy, projecting outward to fill that pre-existing empty space. This model treats space-time as a silent, passive stage, an assumption that leaves the origin and the properties of the stage itself unexplained. Solving the deepest mysteries of the cosmos requires us to look past physical objects and examine how the universe processes data. Physicist John Wheeler proposed a concept called it from bit, suggesting that every particle and force in our reality is built from raw information. To truly understand the fundamental nature of our reality, we must first mentally delete space, time, and matter entirely. Once the physical stage is removed, all that remains is pure, unadulterated data. Before the Big Bang, the universe existed as a single, dimensionless node of pure data, rather than an empty void. This state reached total integration, where every bit of information was perfectly entangled with every other bit, leaving no room for distance or separate parts. The single glowing point violently shatters like a glass marble, breaking into millions of distinct, isolated glowing particles. This system operates on the law of conservation. The universe neither creates nor erases information. While the total sum remains constant, the data shifts from a state of perfect integration into a highly distributed network. The Big Bang was a phase transition, much like ice melting into water, where the cosmic data permanently lost its unified structure. If space does not exist yet, where do these newly disconnected bits of shattered information go? Space-time is dynamically generated as the physical exhaust needed to hold and separate this broken, disconnected data. The universe expands because quantum entanglement continues to decay, demanding more geometric exhaust to accommodate the falling data. Energy, in this model, represents the mathematical rate at which this underlying data integration drops. Gravity describes the geometric resistance of scattered data nodes attempting to return to their original, unified state. Space, expansion, and energy are the mechanical byproducts of a shattered quantum hard drive. Looking at the present-day universe through this lens changes how we perceive the massive structures around us. Stars, planets, and humans are rare, stubborn clusters of high-density information that still maintain a high degree of local integration. The cosmos is a complex process of data continuously decoding itself. Space-time acts as the physical memory of the original perfection shattering, recording every bit of data as it drifts apart.